Hello and welcome to this Python tutorial. Alright, so we just built the architecture of our neural network with the init function of our network class, and now we're going to make a second function, which is going to be the forward function, and that's the function that will activate the neurons. That is, it's the function that will perform forward propagation. So let's do this. Let's make this function. Let's call it forward, as we just said, and this function is going to take two arguments. First is, as usual, self, to be able to use the variables of the object, because we're going to use fc1 and fc2. So we need this self to be able to use these variables. And then we're going to need a second argument, which is our input. And we're going to call it state, because state is exactly the input of our neural networks. That's the states that are the inputs entering the neural network. And then, as output, we will have the Q values of the three possible actions: go left, go straight, or go right. But we don't need to input it as an argument here because that's exactly what we want to return. So this forward function is not only going to activate the neurons, but also and mostly it will return the Q values for each possible action, depending on the input state here. Alright, so that's the two arguments we need. And now let's go inside the function and let's specify what we want it to do. Okay, so the first thing we're going to do is activate the hidden neurons. And we're going to call the hidden neurons by the variable x. So x represents the hidden neurons. And so how are we going to activate them? Well, of course, we're going to take our input neurons. We're going to use our first full connection fc1 to get the hidden neurons. And then we're going to apply an activation function on them, which will be the rectifier function. So how are we going to do that? Remember, we imported the torch.init.functional module that contains all the functions in PyTorch to implement a neural network, and we gave it the shortcut f. So actually what we're going to do now is we're going to use one of these functions from the functional module, and this function is the ReLU function. So what is ReLU? ReLU is the rectifier function that you saw in the intuition lectures. That's just the name given to the rectifier function. But since this function is taken from nn.functional, which was given the shortcut f, we need to type here first f dot, and then that's where we can take this function. And actually, if I type re, here we go, we have the ReLU function. So that's the rectifier function that will activate the hidden neurons, that is x. So in this ReLU function, now we understand perfectly what we have to input. That's the neurons that we want to activate. That is the hidden neurons. And so to get these hidden neurons, we're going to take our first full connection fc1, which we will apply to our input neurons to go from the input neurons to the hidden neurons. So let's take our first full connection fc1, but our first full connection is a variable of our object. Therefore, we need to type here first self.fc1. Here we go. That's the first full connection of our neural network. And inside this first full connection, we're going to input our input states to go from the input neurons to the hidden neurons. And so since we gave it the name state, well, here we have to input state. And there we go. We now get activated hidden neurons. All right, and now that we have the hidden neurons, we are going to return the output neurons. So next line, and as you understood, the output neurons correspond to our actions, but these are not the actions directly. These are the Q values, because we're building a deep Q-learning model that combines a deep learning model to Q-learning, and therefore we use Q-learning here to get the Q values for each of our actions. And then later, using a softmax or an argmax, we will get the final action. So here, the variable I'm about to introduce will correspond to the output neurons. And since the output neurons are the Q values, well, I'm going to call this variable Q values. There we go. So Q values. And now we directly take our full connection, which is the variable fc2, but a variable from our object. So we take here self.fc2. And of course, here we input the neurons of the left side of this full connection. That is what we got from the first line, which is x. So x, there we go. We now get our Q values. That's the output neurons of our neural network. Okay? And then last line of code, of course, this forward function is used to return these Q values. So we just have to add a return and simply Q values. and that will return the Q values for each possible action: go left, go straight, or go right. Alright, so congratulations, we're done with our first class, and actually we're done making the architecture of the neural network. Remember, this is not a finished job. You can always improve the architecture of the neural network by trying different ones. So feel free to do that by adding more neurons here. For example, if you want to add 50 hidden neurons, you can just replace the 30 here and the 30 here by 50, 50 and 50. And then you can add some more hidden layers by making some new full connections. Well, that's really the job of an artist. There is no general rule of what would be the best architecture in each situation, so that's why we have to experiment. But let's already try with that. You will see that we will get eventually a pretty good self-driving car. Alright, and now we're going to make the next class, which is about experience replay, and we will be making that in the next 3 tutorials. Until then, enjoy AI!